This is Cloud Computing, Chapter 4, Part 2, Implementation of Cloud Computing. This video covers public and private cloud computing, focusing on the changes to cloud computing environments. We are in Section 4.2, Public and Private Cloud Computing. Cloud deployment models help us understand how a cloud system is organized and used. First, they describe where cloud resources are hosted. This means the location of the servers and systems. They might be in a public provider's data center, inside a company building, or a mix of both. Second, deployment models explain who controls the infrastructure. In some cases, the cloud provider manages everything. In other cases, the organization manages its own servers and systems. Third, they define who can access the services. Some cloud services are open to many users, while others are limited to a specific organization or group. For example, a small startup might store files using Google Drive, where the infrastructure is managed by the provider. A bank, however, may run its own private cloud, where only internal staff can access the system. So when we understand these deployment models, it helps organizations choose correctly based on their needs, security requirements, and available resources. A public cloud is a cloud environment where the infrastructure is owned by a cloud provider. This means the servers, storage, and network are managed by companies such as AWS, Microsoft Azure, or Google Cloud. In a public cloud, services are offered to many users. Different organizations and individuals can use the same cloud platform at the same time. Even though many users share the system, resources are shared securely. Each user's data and applications remain separate and protected. Another key point is that access is provided through the internet. Users can connect to the cloud from anywhere using a web browser or application. For example, when a company stores documents in Google Drive or runs an application on AWS, they are using a public cloud. The infrastructure belongs to the cloud provider, the services are available to many users, and everything is accessed through the internet. Public cloud platforms have several important features. First is shared infrastructure. This means many users use the same cloud system, but their data remains separate and secure. Second is on-demand access. Users can start using cloud services anytime, without waiting to buy or install servers. Third is pay-as-you-use pricing. Organizations only pay for the resources they actually use. Another feature is high scalability, which means the system can easily grow when demand increases. For example, a small online shop running its website on Amazon Web Services, AWS, can quickly add more servers during a big sale. This shows how public cloud is designed for flexibility and cost efficiency. Public cloud is commonly used for many everyday services. One common use is web applications. Many websites and mobile apps run on public cloud platforms such as AWS or Google Cloud. It is also used for online storage, for example services like Google Drive or OneDrive, where users store files on the internet. Another example is email services, such as Gmail or Outlook. Public cloud also supports learning platforms like Google Classroom or online university systems. In these systems, users do not manage physical hardware. The cloud provider handles the servers and infrastructure. Public cloud offers several advantages for organizations. One advantage is low initial cost. Companies do not need to buy servers or build a data center. Another advantage is fast deployment. Systems can be launched quickly because the cloud infrastructure already exists. Public cloud also provides easy scalability, which means resources can increase easily when demand grows. There is also minimal maintenance responsibility because the cloud provider manages the hardware and updates. For example, a startup can launch a website on Amazon Web Services without owning any servers. Because of this, public cloud is often suitable for organizations with limited budgets. Public cloud also has some limitations that organizations should understand. One limitation is less control over infrastructure. The servers and hardware are managed by the cloud provider. For example, if a company runs its system on Amazon Web Services, the company cannot physically upgrade the server, such as adding more RAM or replacing a hard disk. In a traditional data center, the IT team could make these changes themselves. Another limitation is dependence on internet connectivity. Cloud services require internet access. For example, if an office internet connection fails, employees may not be able to open files stored in Google Drive. There are also shared environment concerns. Public cloud infrastructure is used by many organizations at the same time. For example, many companies may run applications in the same Microsoft Azure data center. Even though the systems are separated, some organizations may worry about performance during heavy usage. Finally, security relies heavily on provider controls. When using services such as Gmail or AWS, organizations depend on the cloud provider to manage security and protect the infrastructure. A private cloud is a cloud environment that is dedicated to one organization. In simple words, The cloud system is built only for one company or institution. Because of this, it is not shared with others. Other organizations cannot use the same cloud system. This helps keep the data and services more controlled. A private cloud can be hosted on-site or remotely. On-site means the servers are located inside the organization's own building or data center. Remotely means the servers are placed in another data center, but still belong only to that organization. Another important point is that access is restricted to authorized users. This means only approved staff, systems, or devices are allowed to use the cloud resources. For example, a bank may use a private cloud to store customer financial data. This system is dedicated to one organization, not shared with others, and only authorized users such as bank employees can access the information. This helps protect sensitive data while still using cloud technology. Let us look at the key characteristics of private cloud. First, private cloud uses dedicated infrastructure. This means the servers and storage are used by only one organization. They are not shared with other companies. For example, a bank may run its own cloud servers inside its own data center so that customer data stays within the company. The second feature is greater control. Because the organization owns or manages the infrastructure, it can decide how the system is configured, updated, and monitored. For example, an IT team can choose exactly how servers are set up or when maintenance is done. Next is custom security policies. The organization can design its own security rules based on its needs. For instance, a hospital may apply strict encryption and access rules to protect patient records stored in its private cloud. Another feature is limited user access. Only specific employees or departments are allowed to use the system. This helps prevent unauthorized access to important data. So overall, a private cloud focuses on control rather than cost savings. Companies choose this model when they want stronger control over systems, security, and sensitive information. Let us see how private cloud is used. Private cloud is often used for sensitive data systems. These are systems that store important or confidential information. For example, a hospital may store patient medical records in a private cloud so the data stays protected and controlled by the hospital. It is also used for internal enterprise applications. These are systems that are used only inside a company. For instance, a company may run its employee management system, payroll system, or internal database in a private cloud so only staff can access it. Another common use is in regulated environments. Some industries must follow strict rules set by governments or regulators. For example, banks and financial institutions often use private clouds because they must follow strict data protection laws. Because of these reasons, organizations manage or closely control operations when using private cloud. This means the company keeps strong control over how the system runs, who can access it, and how the data is protected. Now let us look at the advantages of private cloud. The slide shows several key benefits that private cloud provides. The first advantage is high security control. In a private cloud, the organization can closely manage how data is protected. For example, a bank can control who accesses the system and apply strong encryption to protect customer information. The second advantage is custom configuration. This means the organization can design and adjust the system based on its own needs. For instance, a company can configure its servers, storage, and network settings to match its internal applications. Another advantage is better compliance support. Many industries must follow strict rules for handling data. Private cloud helps organizations meet these requirements because they have more control over how the systems operate. Because of these advantages, private cloud suits organizations with strict requirements. Companies that handle sensitive data or must follow strict regulations often prefer this type of cloud environment. Now let us look at the limitations of private cloud. One limitation is higher cost. Organizations must buy and maintain their own servers, storage, and network systems. For example, a company running its own data center must pay for hardware, electricity, and maintenance. Another limitation is greater management responsibility. The organization must manage updates, security, and system monitoring by itself. There is also limited scalability compared to public cloud. Expanding resources takes time because new hardware must be installed. Because of this, it requires technical expertise to manage the system properly. This slide shows a public versus private cloud comparison. On the left is the public cloud. Public cloud uses shared resources, which means many companies use the same cloud infrastructure. Because resources are shared, the cost is usually lower, so it offers lower cost. Public cloud also provides high scalability, meaning companies can quickly increase storage or computing power when needed. For example, an online store using AWS can add more servers during a big sale. On the right is the private cloud. Private cloud uses dedicated resources, which means the infrastructure is used by only one organization. This gives the company higher control over security, systems, and data management. However, this also leads to higher cost because the organization must maintain its own infrastructure. So in summary, The choice depends on organizational needs. Some companies prefer lower cost and flexibility, while others need stronger control and security. This slide explains the factors influencing cloud deployment choice. In simple words, organizations must consider several key factors before choosing a cloud model. The first factor is budget. Some organizations prefer public cloud because it usually has lower starting cost. For example, a small startup may choose public cloud services like AWS or Google Cloud because they only pay for what they use. The second factor is data sensitivity. If the data is very confidential, organizations may choose a private cloud to protect sensitive information. For example, hospitals storing patient records may require stronger control. Another factor is compliance requirements. Some industries must follow strict rules and regulations. Banks and financial companies often use private cloud environments to meet these legal requirements. Next is technical skills. Managing private cloud systems requires skilled IT teams. If a company does not have enough technical expertise, it may prefer public cloud services, where the provider manages most of the infrastructure. Finally, there are scalability needs. If a system must grow quickly, public cloud is often easier to scale. So remember, there is no universal best option. The best choice depends on the organization's needs and situation. This section, Section 4.3, will cover the changes to cloud computing environments. This slide explains the nature of cloud computing environments. Cloud environments are not static, meaning they constantly change. One reason is technology improvements. New technologies are created to improve performance. For example, cloud providers may introduce faster processors, better storage, or new services, such as AI tools and container platforms. Another reason is user demand. For example, during the World Cup final match, millions of people may watch live streaming at the same time. The cloud system must quickly add more servers to support the large number of users. Finally, cloud systems must adapt to security requirements. New cyber attacks or hacking techniques appear over time. For example, if hackers discover a new way to attack online systems, cloud providers must quickly update their security systems to protect data and services. This slide explains the evolution from traditional IT to cloud. In traditional IT environments, systems used fixed hardware, meaning companies had to buy physical servers and install them in their own data centers. When systems needed improvement, they required manual upgrades, such as adding new servers or replacing storage devices. In cloud environments, systems use virtual resources, such as virtual servers, storage, and databases. For example, a company can create a virtual server on AWS or Azure within minutes. Cloud systems also support continuous improvement, where cloud providers regularly update services without changing physical hardware. This shift changes how systems are managed. This slide explains scalability as a major change in cloud computing. Cloud environments allow rapid scaling, meaning resources can increase quickly when needed. Scaling can be vertical or horizontal. Vertical scaling means increasing resource size, such as adding more CPU, memory, or storage to one server. Horizontal scaling means adding more instances. An instance is another running server created from the same setup or configuration. It is like starting another copy of the same server so they can work together. For example, during a big online sale, a website can create several more servers to handle many users. This helps cloud systems support changing workloads. This slide explains elastic resource allocation. Elasticity means resources can change automatically depending on system usage. Resources can increase during high demand and decrease during low usage. For example, during the World Cup final live stream, millions of people may watch at the same time. The cloud system automatically adds more servers to handle the large number of viewers. After the match ends and fewer people are watching, the system reduces the number of servers. This flexibility helps cloud systems run efficiently, so this improves efficiency and reduces waste. This slide explains automation in cloud environments. Cloud environments rely heavily on automation, which means many tasks are done automatically by the system. One example is resource provisioning. This means the cloud can automatically create servers, storage, or databases when they are needed. For example, if many users access a website, the cloud system can automatically start new servers. Another function is system monitoring. Cloud platforms continuously check the health and performance of systems. If a server becomes slow or stops working, the system can detect the problem quickly. Automation also supports load balancing. This means the system distributes user traffic across multiple servers so that no single server becomes overloaded. Because of automation, manual effort and errors are reduced, and cloud systems can operate more efficiently. This slide explains continuous updates and improvements in cloud environments. Cloud providers update their environments regularly. These updates include performance improvements, which make cloud services run faster and more efficiently. For example, cloud providers may upgrade their servers or improve system software so applications respond more quickly. Another update is security patches. These are updates that fix security weaknesses and protect systems from new cyber threats. For instance, if a vulnerability is discovered, the cloud provider quickly updates the system to keep data safe. Cloud providers also introduce new features. Platforms like AWS, Azure, and Google Cloud regularly release new tools such as AI services, databases, or analytics tools. The advantage is that users benefit without managing updates themselves, because the cloud provider handles the updates automatically. Let us now look at security changes in cloud environments. Cloud security evolves continuously because new cyber threats appear over time. One improvement is improved access controls, which help ensure only authorized users can access systems and data. Cloud platforms also provide better monitoring tools. These tools watch system activity and quickly detect suspicious behavior. Another improvement is stronger encryption methods, which protect data by converting it into secure coded information. For example, cloud platforms like AWS and Azure continuously improve these protections. This is important because security must adapt to new threats. Another important change in cloud computing is cost management. Cloud environments introduce usage-based costs, which means organizations pay based on how much cloud resources they use, such as servers, storage, or data transfer. Because of this, organizations must monitor resource usage. For example, a company using AWS may check how many virtual servers or storage services are running to avoid unnecessary costs. They also need to control unnecessary services. If some cloud resources are not being used, they should be stopped or removed to reduce spending. Organizations must also plan budgets carefully before running cloud systems. In cloud environments, cost awareness becomes an ongoing task because resource usage can change at any time. In modern cloud environments, systems are designed to provide better monitoring and visibility. Cloud platforms offer real-time monitoring, which means the system can continuously check the status of servers, applications, and networks. If something goes wrong, the system can quickly detect the issue. Cloud systems also provide usage analytics. This helps organizations understand how their cloud resources are being used, such as how much storage, computing power, or network traffic is being consumed. Another important feature is performance dashboards. These dashboards show system performance using charts and graphs. For example, tools like AWS CloudWatch allow administrators to see server activity and system performance in one place. With these tools, organizations gain better visibility, which helps them make better decisions when managing cloud systems. Cloud computing also changes IT responsibilities. In traditional IT environments, the main focus was hardware maintenance. IT staff needed to install servers, repair hardware, and upgrade physical machines in the data center. But in cloud environments, the focus shifts from hardware maintenance to service management, security planning, and cost optimization. Service management means managing cloud services, such as virtual machines, databases, and storage. For example, an administrator may manage an application running on AWS or Azure without touching any physical server. Security planning is also important. Teams must control who can access cloud systems and protect data using strong security settings. Another responsibility is cost optimization. Because cloud uses pay-as-you-use pricing, organizations must monitor usage and avoid running unnecessary services. Because of these changes, skills requirements also change. IT professionals now focus more on managing cloud services rather than maintaining hardware. Another important improvement in cloud systems is reliability. Cloud environments improve reliability through redundancy, failover mechanisms, and distributed systems. Redundancy means having extra copies of resources. For example, cloud providers may store the same data in multiple servers so that if one server fails, another copy is still available. Failover mechanisms automatically switch to another working system when a failure happens. For instance, if a server running a website stops working, the cloud system quickly moves the traffic to another server. Cloud platforms also use distributed systems, where services run across many machines instead of only one. Because of these methods, failures are handled with minimal user impact, and most users may not even notice when a problem occurs. Modern cloud systems are designed to provide strong flexibility. Cloud environments support rapid deployment, which means applications can be launched very quickly. For example, a company can start a new server or website in a few minutes using services like AWS or Google Cloud. They also allow easy configuration changes. If a system needs more storage or computing power, administrators can adjust the settings through the cloud platform without changing physical hardware. Another benefit is experimentation and testing. Developers can quickly create a temporary environment to test a new application, feature, or update. If the test fails, the environment can simply be removed. Because of these capabilities, cloud environments provide flexibility that helps organizations try new ideas faster. This is why this flexibility supports innovation in modern cloud computing. Modern cloud environments also bring several challenges. One challenge is managing frequent changes. Cloud systems are updated regularly, so IT teams must constantly adjust configurations and services. Another challenge is maintaining security. Because data and applications are online, organizations must protect them from threats such as unauthorized access or hacking. Organizations also need to focus on controlling cost. Cloud services use pay-as-you-use pricing, so if companies run too many servers or store too much data, the cost can increase quickly. Another concern is ensuring compliance. Some industries must follow strict rules for storing and protecting data, such as financial or healthcare systems. For example, a bank using cloud services must carefully manage security settings and follow data regulations. Because of these challenges, cloud changes require careful planning to keep systems secure, efficient, and cost-effective. Cloud environments change over time, so organizations must learn how to adapt. First, organizations need to update policies. As cloud technology evolves, rules about data storage, security, and system access must also be updated to stay safe and organized. Second, companies must train staff. Employees need new skills to manage cloud services, such as monitoring cloud systems, managing permissions, or controlling resource usage. Organizations should also review cloud usage regularly. Because cloud services use usage-based pricing, teams need to check which services are running and whether they are still needed. For example, a company using AWS may review its virtual machines and storage every month to avoid paying for unused resources. By doing these steps, organizations can adjust to cloud changes effectively. This is why adaptation ensures long-term success in cloud computing. Changes in cloud environments directly affect several important areas of system development. One area is application design. When developers build cloud applications, they must design them to work well in cloud environments. This often means designing systems that can run across multiple servers and adjust when the number of users increases. For example, a video streaming platform running on AWS may design its application so it can automatically use more servers when many people start watching at the same time. Another area is deployment strategies. In cloud computing, applications can be updated and deployed much faster than in traditional IT environments. Instead of installing software manually on physical servers, developers can upload a new version of the application directly to the cloud platform. For instance, a developer can deploy a new update to a web application on Google Cloud within minutes. The third area is performance optimization. Developers must ensure that cloud applications run efficiently by using resources such as computing power, memory, and storage wisely. They may adjust how the application processes data or increase system resources when needed to maintain good performance. Because cloud environments are always evolving, developers must remember an important principle: developers must design for change. This means applications should be flexible and able to adapt when new requirements, technologies, or workloads appear. This approach helps cloud systems remain reliable and efficient over time. To summarize this part of the chapter, we covered 4 key points. Public and private clouds serve different needs, and deployment choice depends on control and cost. We also noted that cloud environments change continuously, driven by scalability, automation, and security requirements. Thank you for watching this video. Cloud computing expands possibilities, and it is crucial to secure every layer of the cloud environment.